We're looking now at page 30, number 10. Page 30, number 10. What is the average acceleration of a tennis ball that has an initial velocity of 6 meters per second east and a final velocity of 7.3 meters second west if it is in contact with a tennis racket for 0.094 seconds? This is just the same kind of questions as 7 and 8. The only little challenge on this one, it's to think about the velocity and what you'll actually have as your delta V on at the numerator. So this one, again, same formula. V delta t, and we know delta t. It's 0.094. We're looking for acceleration. We're just needing to find, right now, to establish what would delta v give us numerically. And we have everything right now. We just have to determine delta v. So looking by what we have here, the initial velocity, so v1, is 6 meters per second east, and v2 is 7.3 meters per second, but now that one is west. Okay, so the book mentions earlier in the pages, I just remember from when I read it over, when you're going to compare vectors sort of opposite directions like this, you're just going to need to convert one of them in the other direction. And it actually doesn't matter which one you pick, both will work. So I'll take this one as my ultimate answer as the going east. So I'll convert this one as east. And it's really, really straightforward. If this is a vector 7.3 like this, okay, of length 7.3 going west, right? So straight going west. Properties of vectors say that this, if you want to rewrite it, this is the same as this vector, the opposite direction vector, basically, right? 7.3, but you see me coming with a negative. Because the negative changes the direction of the vector. That's all it does. So this is what we're going to use as a property here. So we're going to say that v2 is actually negative 0.73 meters per second east. So once you have this, you just plug in, and it will, you'll just land on the answer. So using v2 minus v1, overall it's preferable to go that way, so let's do that. Minus v1, right? So I'm forgetting the rest of the equation because you guys can just rearrange that on your sheet. That's really straightforward. So v2 was negative, so negative 0.73 meters per second east, minus, so you see what's going to happen. It's going to get bigger, but negative, minus 6 meters per second east. And that's going to give us negative 13.3 meters per second. Now my direction total is east. Now, why doesn't it matter that I converted this one to east versus this one, it really makes no difference, because if I convert this one to west, the signs are just going to change. I'm okay showing that. I don't know if I'll have enough space here. I have to remember my values. So if I go same rational, but now I'll change it just as I write them. So so this is my V2, but now I'll convert it to west, so it comes back to positive. This is west. And then here, I'll end up with positive, right? Because this one's going to change sign. Because I still have the minus, but this one's going to get a double minus here, double negative, as I go west, as I change it to west. It's not here. I'll just cancel my little bar there, just make it clear. So it turns out to be a positive here, so I'm going to end up being +6, and notice the signs what just happened. Now this is west. Oh, beautiful. That's positive 13.3. Okay, so that's all you needed to do for 10.